All right, so this is the question for ATP. This can obviously be utilized by students who are appearing in GCE or IGCSE. We call this planning question because you will be given a set of apparatus and you will be given a task that you're supposed to basically perform and obviously you know design your own experiment accordingly and follow the steps which is being advised in the question. So let's see, usually this is 7 marks question. So let's just solve this question and hopefully this will help you for understanding the pattern, and obviously then you'll be practicing more questions of the same kind to polish your skill on this particular question. Okay, so starting with the question, they say a student is investigating resistors connected in parallel. This is the first important point, that you just get the idea that what is this experiment all about. All right, so the first thing. Now next, the following apparatus is available. So you are given ammeter, you are given voltmeter, you are given power supply, variable resistor, switch, connecting lids, a box of identical resistors. Now, first important thing here is that you're not supposed to use all of these apparatus, but you can choose obviously as many as you can use. So it is advisable if you can use more, that's good, but keep your circuit or keep your diagram as simple as possible. Okay, right, not to complex things for yourself. So let's proceed. Now it says plan an experiment to investigate how the combined resistance, okay, how the combined resistance of resistors connected in parallel. Now this is important. They are telling you it should be connected in parallel. Obviously you have the choice of connecting in series as well. Depends on the number of resistors. Now this sentence is very, very important because you understand the whole experiment, what is it all about and what you're supposed to do. They're saying plan an experiment for yourself and tell us how would you investigate the combined resistance of that circuit where the circuits will be connected in parallel. Okay, and for number of resistors means that maybe you have two resistors in parallel, and then how would you find combined resistance practically. Then if you have three resistors in parallel, how can you calculate the combined resistance practically? And if you have 4, 5, 6 all in parallel, then how you can basically determine the combined resistance. I'm using the word practically because you're not supposed to calculate. Okay, now here they say you should, a few guidelines are given to you and these are very important. They say draw a diagram. Now this is your first step. Okay, draw a diagram. This is your first step, obviously. So what you're supposed to do is you'll be drawing a diagram. What should you include in the diagram? Now just recall, you have resistors, so you can use resistors 2, 3 or so. Then you have obviously a power supply, a switch, and a voltmeter, ammeter, etc., things like that. So these are the things that should come to your mind at this point. Now they say you could use to determine the resistance of resistors connected in parallel, show only two resistors in your diagram. Now here is a restriction that you can only connect the resistors in parallel. This is the first restriction, and the second restriction is only show two resistors in your diagram. So means that they're just making it simple for you, that you may not just go and adding more and more resistors. It will take more time. Just draw a circuit with two resistors in parallel, that is enough. That's what the question is saying to you. Fine, let's go on. What next? Now explain briefly. Now this is your step 2. We say the procedure part, explain the procedure, how you would carry out this experiment. Okay, the third stage comes that where you are actually dealing with the data, means the readings that you actually record from the voltmeter, from the ammeter and so, and how would you present that data, and then how would you analyze that data. These are two steps now. So draw, as they say, draw a table or tables, depends. Okay, so we are in step 3 now. Draw a table or tables with column headings, right? With column headings. Now, as I said, here you would have two steps like step 3 and 4 together. One first is to present your data, and the next step would be how to analyze your data. You'll understand later. Now here they say with column headings. So column headings, whenever you're asked to write column heading, whether that is in graph or whether that is in table, you always have to write a quantity slash unit. So if you have more quantities, then obviously you would have a separate column for each quantity slash the unit of that quantity. For instance, you have volt slash V, you have current slash ammeter, like that, resistance slash ohm. So always do that. Fine. Now they say how you display, and as I just said that you are dealing here how to present your data and as well as how to investigate your data. And lastly, they say you are not required to enter any readings into the table. Now they may say or may not state this thing. You are never supposed to write down numbers in the table in this question. Okay, just make a table, okay, with the column headings, and that's it. You will see later as I'll draw it over here as well. Fine, let's go on. Let's take a start. The first step, as we said, drawing a diagram. So we just made our mind we should have two resistors, okay, and we're supposed to find out combined resistance. So what we can do, two resistors, combined resistance, obviously we need to have a power supply, we need to have a switch. Fine. Now how can I find the combined resistance? I can find combined resistance by using the Ohm's law, right? We say that, let I say R equals to V over I. Now I need to find V, so for V I would install voltmeter, and for I would install ammeter. Okay, now you also know how to install voltmeter. It should always be parallel, and ammeter should always be in series. Now let's see how to basically draw a diagram. Okay, drawing a diagram. First thing, what I've done, I just drawn two resistors in parallel. See, this is resistor 1, this is resistor 2, and they are in parallel. How you can say they're in parallel? Obviously, they're making a separate loop, or you can easily say that there are more paths for the direction of current. If current is coming this way, then there is a branch. Some current would pass here, some current would pass there. So whenever there are more path for current, means more than one path, we consider that circuit as parallel. Next, I'm connecting a switch, okay, a power supply or a battery. I should install an ammeter. Where should I install an ammeter? The ammeter, if I install an ammeter over here, that will only give me the current across this resistor. If I install ammeter over here, that will only tell me about the current through this resistor. Okay, if I draw ammeter somewhere here or maybe somewhere here, that can give me current across the whole circuit, because here at the branch the current will split through these two paths, and here out of the branch the current will be combined. So we say we are drawing the ammeter in series, and at the position where I can calculate the total current across this circuit. As you can see here, what I've done, I've just labeled each of the component that I have in the circuit: ammeter, switch, power supply, and fixed resistors. I can find out the potential drop across the parallel combination of resistors divided by the current. So for that I need to install a voltmeter, but the voltmeter should always be parallel. So parallel to what? If I draw a voltmeter over here like this, will that be fine? Yes, that can be fine. And this voltmeter can give me reading across this resistor and this resistor. We should draw the voltmeter somewhere here. Okay, now this can measure the the potential drop across this branch, or you can say across this resistor, or you can say across this resistor, because they will be same anyway. Okay, draw the voltmeter parallel, now in parallel to these resistors. Okay, now whatever reading we have over here, obviously the voltmeter is telling us And you also know that the same reading will be over here as well. Means if you have, for instance, 10 volts over here, this is the reading of this resistor. Okay, this resistor is also having 10 volts because they are in parallel. You know this. So the circuit is complete now. How much marks you should get for this? You should get basically drawing the circuit correctly, you get 1 mark for that. Okay, drawing all the components correctly like voltmeter and ammeter series and parallel properly, you get another mark. And labeling all the components, you get another mark. So altogether you'll have 3 marks. All right, step 2 now. Carrying the investigation means we need to write the method how we are basically using this circuit to calculate the combined resistance of these two resistors when they are in parallel, or maybe more resistors when they are in parallel. So the first point should be to set up the apparatus as shown in the diagram. Okay, from here we take start. Record the reading on ammeter and voltmeter. Okay, when you set up the circuit, means your circuit is switched on. Now you should measure the value or record the value on the voltmeter for the voltage or potential drop, and ammeter for the total current in the circuit. Okay, what next? Determine the net resistance of the circuit using the formula. You are using Ohm's law, R equals to V over I. R over here is for combined resistance of the circuit. V is the voltmeter reading and I is the ammeter reading. So add the third resistor in parallel. Now we're going ahead. Now we are having another resistor. We're not drawing it on the diagram because they told us to just show 2 resistors in parallel, okay, in the diagram. Now we are saying that, okay, next would be if we add third resistor in parallel in the circuit, and we will do the same again. We will record the voltmeter and ammeter reading, okay, and we will redetermine the value of resistance using the same equation. Now we will add another resistor again in parallel, and we will repeat the same 2 steps for recalculating the total resistance across the new circuit. Obviously we are adding more and more resistors. Right. So this is how it goes. Now what next? Now what to do with this data? We are keep basically recording the readings on voltmeter and ammeter, and we are adding resistors in parallel. What to do with this data? Now is the time for the next step where we are supposed to present the data. So presenting the data in a table with the following quantities. What quantities you should choose? Okay, obviously resistors, obviously voltmeter reading, ammeter reading, yeah, combined resistance, and number of resistors that you are basically using in each time in the circuit. Now number of resistors that we have, first we had 2 resistors, now you have 3, now you have 4, and so on. Each time you are taking reading from the voltmeter, you are writing it over here. Each time you are taking reading from the ammeter, you are writing it over here. And each time you are calculating the total or combined resistance, you are writing it over here. What is important? Look here, voltmeter reading slash V slash volt. First V is for potential drop, second is for volt. Over here, ammeter reading means I slash ampere. This should be ampere. Okay, and next combined resistance, R slash ohms. So what you are doing basically, you are writing the quantities slash units, and you get 1 mark for this. Okay. Now next is how to analyze this data. You say the combined resistance is dependent on the number of resistors. By adding more and more resistors, the combined resistance value will basically be affected. That's why I'm writing combined resistance in y-axis and number of resistors in x-axis. Here is an important point for you. Let you feel that, oh, okay, I'm a bit confused, you know, where should I write the data, either on y-axis or on x-axis. Then you can just write, plot a graph of these 2 quantities rather than you're drawing the graph, because if you are doubtful, then you should avoid. Okay, because if you write it incorrectly, you may lose mark. If you just write the sentence, you may get mark. You definitely will get mark. Okay, what's the sentence? For analysis based on recorded data, plot a graph of combined resistance with respect to number of resistors. Okay, so if you are confident perfectly, you can go for drawing this graph. If you feel you're doubtful, do not draw the graph, just write the sentence. Okay, you'll get 1 mark for this. Okay, last, you have one more point that we usually and we should add, that is safety. So what safety can be done over here, what we can do as a safety precaution. So as a safety precaution, what you can do is we can say that you know wear gloves. Okay, that can be one safety. The other can be switch on the circuit for short intervals of time to avoid overheating of the circuit. Just switch on the circuit, record the data, and then switch it off. So all the time it is suggested to include one safety precaution point. Okay, so how we get marks now? Let's go now and just see how much marks you have scored. So for the diagram, we get 3 marks, as we had explained earlier also. You draw the circuit properly, you get 1 mark. You plug in the components correctly and label them, you get another mark. And you draw the voltmeter and ammeter in series at correct positions, you get another mark. So altogether you get 3 marks. Recording the values of ammeter and voltmeter and determining the net resistance or total resistance of the circuit, you get 1 mark for this. Then you get another mark for repeating this process. Okay, and lastly you say that repeat the process for few sets of readings. Obviously, if you want to plot the graph, you have to have at least 4 or 5 sets of readings or 6 sets of readings. So mentioning the repeat, you get another mark. Okay, presenting the data, you get another mark. Just the table and uh, quantity/units correctly. Analyzing the data, another mark. And lastly, safety precaution. Okay, so altogether you have 7 marks in this question. All right, so what you can do is you can just follow the pattern of this question the way we did and try to solve 4 or 5 questions from different past papers, and definitely you will feel more confident on this question. And one last thing is that in each ATP paper in recent years, such question is included based on different topics. Thank you.